This case study examines how a major U.S. power utility overcame high-temperature corrosion challenges in its GE7HA gas turbine using IGS's HVTS cladding technology. A major power utility in the southeastern United States faced severe operational challenges with its GE7HA heavy-duty gas turbine. The turbine experienced high-temperature corrosion and related spalling, leading to frequent maintenance, forced outages, and operational inefficiencies. The GE7HA turbine operates under extreme conditions with temperatures exceeding 1,000 degrees Fahrenheit. Unprotected cast steel surfaces in the compressor discharge and combustor sections suffered from corrosion, generating oxide flakes that traveled downstream. These flakes clogged cooling channels, causing wear and premature failure of blades, vanes, and other critical components. Frequent repairs due to component wear increased maintenance expenses, while forced outages disrupted operations and impacted overall plant reliability and performance. Newer generation heavy-duty gas turbines, including H-class machines, are particularly susceptible to these issues due to their advanced design and higher operating temperatures. While some OEMs apply coatings during manufacturing, many deployed units remain uncoated, leaving them vulnerable to oxidation and spalling. To address these challenges, Integrated Global Services provided a comprehensive and proprietary solution. The project was executed during a scheduled maintenance outage in April 2023, and the IGS applied HVTS cladding to several critical turbine components, including the compressor discharge casing, outer turbine shell, diffuser or splitter, inner barrel, and armways covers. The total on-site time for the project was 8.5 days, completed over 17 shifts, with the critical path taking just 3 days. Surface preparation involved sponge jet blasting to ensure optimal cleaning with reduced dust and debris, following SSP CSP5 white metal blast cleaning specifications for precise profiling. The IGS Clearstream filtration system ensured compliance with hexavalent chromium exposure limits, maintaining a safe and controlled work environment. Following nearly 8,000 hours of operation and 52 starts, a detailed inspection in May 2024 confirmed the success of the HVTS application. The protective layer remained in as-applied condition with no signs of thickness loss, spalling, or cracking. High-temperature corrosion was completely eliminated in all treated areas. Reduced maintenance needs and fewer forced outages improved turbine reliability and performance. These results demonstrate the long-term durability and effectiveness of IGS's HVTS cladding in harsh, high-temperature environments. The IGS HVTS cladding solution provided a permanent and cost-effective method to address high-temperature corrosion and spalling in the GE7HA turbine. By preventing oxidation and wear, the solution extended the turbine's lifespan, reduced maintenance costs, and enhanced overall operational efficiency. IGS's patented HVTS material was specifically designed for high-temperature environments and validated through multi-year testing in collaboration with OEMs. The high-velocity thermal spray technology ensures dense, impermeable cladding with minimal stress on the substrate material. Custom protective isolation tooling was also used to shield areas not being treated and maintain critical tolerances during application. And that is our episode of the Efficiency and Reliability Podcast. To learn more about HVTS, visit our website at www.integratedglobal.com. See you next time.